but think about the amazing diversity of our users. Diversity in cool applications and breadth and depth of your expertise. From robotic surgery to telecommunication equipment to data analytics. We have a large tent here at Xilinx now that includes hardware designers, software developers, AI and data scientists. Our goal over the next 2 days is to ensure to offer you, all of you, something new and exciting so you can build even cooler applications when you get home. Now to that end, we have a very, very comprehensive agenda. We have 76 hours of sessions here. We have 11 labs and 69 demos. And that should get your creative juices flowing. Victor already talked about how we are launching Vitis, the unified software development platform, this week. I'm super excited to talk about it. It's been a multi-year project for us. We have spent 1,000 man-years building Vitis. It's been a personal passion of mine because I am a software developer at heart. Now, for all of you software developers, data scientists, AI scientists, Vitis is for you. Vitis is for you because it gets you the best out of our adaptable devices. Now, for all of you Vivado users, rest assured, we're going to continue to improve Vivado. We're going to continue to improve Vivado so you can keep up with the increasing design complexity. Now this morning, we are going to focus on Vitis though. We're going to focus on Vitis and show you how we are welcoming some of you newcomers to the Xilinx family. Now before I talk about Vitis and give you some of the details about Vitis, I want to give you some of the context around what guided the development of Vitis. And we see 3 industry trends. The move towards heterogeneous computing, the trend where applications span from cloud to edge to endpoint, and proliferation of AI, the pervasiveness of AI. The first trend is a clear shift from standard CPUs to heterogeneous compute architectures. Traditional CPUs are not able to provide the performance scaling required for some of these compute-intensive workloads. And that is why domain-specific accelerators are coming up, stepping up to take on some of these larger workloads. Now the issue, however, is that the workloads continue to change. They depend on algorithms and standards that continue to evolve. And that is why the adaptable devices such as FPGAs and ACAP devices have started to gain momentum as adaptable domain-specific accelerators, because they can be customized for your domain, for your application, and they can be configured on the fly. The challenge, however, is the programming, the implementation, and integration of all these heterogeneous domain-specific accelerators together, especially for software developers that are not savvy about FPGA design. The second trend has to do with applications that span from cloud to edge to endpoint. Some of the applications start with the cloud and then move towards edge or endpoint to improve latency and even privacy. And some start with the edge or endpoint and start moving towards the cloud to improve scaling and TCO. And some have architectures that are hybrid. They get best of both worlds. So here's an example of a surveillance system. We have camera on the left, we have encode, decode, some object detection, some analytics. Now you can start with an architecture that is cloud-based. You can start with an architecture where the analytics engine, the object detection code is in the cloud, and the video ingestion is in the camera. The camera is a dumb camera that's in this scenario, an inexpensive camera. It moves all the data to the cloud. All the processing is done in the cloud. You can actually improve this architecture potentially by improving your latency and network traffic by just moving the object detection code into an edge server. Now you can go a step further. If you move the analytics code into Edge and move the object detection code into your camera itself. Now this camera becomes a smart camera and it's an expensive camera. Now customers may want to deploy all three architectures to their customers depending on their needs. And so the challenge here has to do with retargeting your application from cloud to edge. And that is exactly the challenge that Vitis addresses. Last but not the least is a trend towards AI, proliferation of AI. AI is being used in a whole host of applications. Smart city, smart retail, autonomous driving. ML scientists are being embedded within your application teams. These ML scientists, of course, need a way to implement their machine learning algorithms from frameworks that are familiar to them, such as TensorFlow, down to these adaptable devices. But the more important challenge is that they need to be able to integrate these machine learning algorithms within a whole application and be able to deploy the entire application on your adaptable device. So you can improve the pipeline, the entire pipeline of application, so it can meet the performance goals. So interestingly, but unsurprisingly, these three trends are intertwined. You do need heterogeneous compute architectures to improve performance for cloud applications as well as embedded applications. AI is being used in cloud as well as edge. And AI algorithms also need heterogeneous compute architecture. They do need these domain-specific accelerators to improve their performance. So you need a unified development environment that can tackle all these challenges and address all these industry trends. And that is exactly the driving force behind Vitis, our unified software development platform. Now, it's a major step forward for us. Vitis is a major step forward for us because it integrates all of the software tools that we have been building. SDK, SDSOC, SDXL, machine learning tool suite, all have been integrated into Vitis. So now we have two very powerful platforms, Vitis and Vivado. Now in fact, Vitis enables embedded developers, application developers, data scientists all to build and deploy their applications onto either Zinc-based systems, ultra-scale-based systems, Alveo, or even in cloud. So, what is Vitis? So, Vitis is a comprehensive tool suite. It allows you to build, run, and analyze your applications. All of the development in Vitis is done in the context of a platform. A platform is a pre-configured system. It has IOs, it has memory, and it has a software API that allows the host CPU to communicate to your target device. To build your application, Vitis offers dedicated compilers. These dedicated compilers are dedicated to your heterogeneous components within the Xilinx device. So Vitis HLS tool will take your C, C++ RTL code and target the programmable logic. The ARM compiler tools will take your C, C++ code and target a processing subsystem. And then you have system compilers and linkers that can stitch all of these heterogeneous components together and help you with the data motion between each of these heterogeneous components. Vitis also integrates an x86 toolchain to allow you to build PCIe-based systems. It also has AIE engine compilers to map your code into AIE engines within Vercel. Now to deploy your application, Xilinx software runtime, this is XRT, is OS independent and platform independent APIs. and they allow you to communicate to your device, manage your application, and manage the motion, data motion between your host CPU and your application. And as Victor said, we are embracing open source. All of the XRT code is open source on GitHub. Now, once you have a prototype of your application, you can analyze your application. You're using the Vitest Performance Analyzer and iterate on your design. You can get better partitioning and better performance. Once you're satisfied with your application performance, you can then deploy it on your target platform. Now, although Vitest is a very comprehensive tool suite, tools are not enough. Tools are not enough, and Xilinx is spending enormous amount of resources and effort in building a whole new set of pre-optimized libraries. We already have about 400 library functions. Some of these library functions are domain specific, domains such as fintech, data analytics, but some library functions can be used across all domains, such as the BLAST library or the DSP library. Again, we are embracing open source. All of these library functions are open source and are on GitHub. Now, once you have the application built, you have the executable, you can target your Zinc platform, and using XRT, the Xilinx runtime software, which is open source, you can now run your application on a Zinc-based system. You can even take the same application and target the Alveo. You can retarget this application using a different platform. This time it's an Alveo platform. You can target Alveo and then deploy it on Alveo. If you want to do scale up, and you want to deploy your application onto multiple racks, multiple servers, Alveo cards sitting on multiple servers, you can now take your application, integrate it with XRT, using Docker, create a container, and create a microservice, and then using Kubernetes, you can deploy it on your rack. Kubernetes has been integrated within the Vitest framework. The Kubernetes plugin is within Vitest, and now you can manage FPGAs and ACAP devices just as you would manage CPUs and GPUs. Now this is all a deployment. For AI developers, Vitest AI provides a very cool way of deploying your AI inference engine. Vitest AI deploys DNN processing units, DPUs. These DPUs are domain-specific accelerators. They are customized for a class of machine learning algorithms. They are software programmable. You can download these DPUs either on your AI engine within Versal or on your FPGA fabric. Once you have the DPUs deployed on your Xilinx device, you can take your machine learning model that you're working on in TensorFlow, and you can then compile it through the Vitest AI stack down to the DPUs. Let me double click on the Vitest AI stack. This is a simplified version of the Vitest AI stack. AI scientists can work in TensorFlow, PyTorch, frameworks that are familiar to them. But they can also use our pre-optimized, pre-characterized AI models. We have about 30 of them. They have been designed for applications such as smart retail, autonomous driving, surveillance. We'll continue to add more and more to these models. You can either use them directly and deploy them directly, or you can continue to create your custom models in TensorFlow. Our compiler, Vitest AI compiler, will help you prune and compress and quantize your AI models, and you can get anywhere between 10 to 20x performance boost. Once you have them compiled, you can download the instruction set onto the DPUs. Vitest AI is fully integrated within Vitest, so you can optimize the entire pipeline of your functions, do whole application acceleration. Okay, so I talked about Vitus, I talked about Vitus AI. Let's now bring it all together. Let's bring it all together and talk about how Vitus actually addresses these three challenges that we talked about earlier. So I'm going to use an example here. This is a smart city example. Again, it has a video on the left, some pre-processing functions, a couple of machine learning algorithms, and some post-processing. Now, in the first approach, we are going to use a cloud-based system. In this cloud-based system, we have a virtual accelerator card that is connected to a CPU using PCIe. In this scenario, we are going to use the Vitus AI tools and map the machine learning algorithms. There are a couple of machine learning algorithms. We're going to map them to the AI engines. Vitus HLS tools will map the video decode and computer vision algorithms onto the FPGA fabric. And the ARM compilers are going to map the object tracker into the ARM processing subsystem. The video analytics and video ingestion reside on the CPU server. And this is a cloud-based system. Now, you can take the same application pipeline, use Vitus, and remap it to a single ACAP device. You can move the video analytics engine into the ARM processing subsystem, and you can take the camera feed and move it to the ACAP as well. So now you have a single embedded device that can do whole application. Vitus and Vitus HLS have allowed you to map your different functions onto different heterogeneous elements within ACAP. They have allowed you to do whole application acceleration, but it has also enabled you to take your application from cloud and move it to edge or endpoint. Now I'm going to use a simpler example, similar end customer scenario, a smart city example, and go through how Vitus and ACAP devices helps you with acceleration. So in this scenario, again we have camera, some pre-processing, post-processing functions, some machine learning algorithms. In the first scenario, I'm going to use a CPU-GPU configuration. In the CPU-GPU configuration, the video pre-processing functions have to reside in the CPU. The machine learning algorithms, the post-processing functions can reside on a state-of-the-art GPU in this scenario. Now, in this configuration only handles 7 channels of 1080p video. Now I'm going to use the same Vitus sort of scenario where I'm going to take the application, use Vitus and move it to a ACAP-based solution. In the ACAP-based solution, the video pre-processing can actually sit on the ACAP device itself. And now this configuration can handle 32 channels of 1080p video. That's a 4.5x improvement in throughput, 1/6 the latency. As you can see, whole application acceleration is an extremely important feature of ACAP devices, and it is a very important feature of Vitus as well. Now we have invested heavily, as you can see, in tools and runtime and libraries, but the solution is not complete unless we have comprehensive training, comprehensive documentation and support. And to that effect, we are harnessing all our expertise from within Xilinx, all our Vitus experts, and we have put together a developer website, developer.xilinx.com. It has been launched as beta today. You can all log into that site today. We're going to continue to improve this website. It already has 30 articles, 30 projects out on the website, but this will be the single hub for developers on Vitus. Now, I have talked about Vitus AI from the Xilinx perspective. Now let's invite on stage some of our customers who will talk about how Xilinx technology, the adaptable acceleration technology, is helping some of our customers. We are going to invite IBM and Micron on stage. Adaptable acceleration is critical, especially in data centers, not just in compute acceleration, but also in network and storage. So IBM and Micron are going to talk about AI and storage acceleration. So first up, please welcome on stage the VP of AI, Machine Learning and HPC at IBM Cognitive Systems. He leads the product and business strategy for AI software and hardware products. Sumit Gupta. Sumit.